Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and I'm joined as usual by Nikolay, founder of Postgres AI. Hey Nick, how are you doing?
Hi, Michael. I'm doing great. How are you?
Good, thank you. And this week is launch week, or was maybe if people are listening in the future.
Later. Yeah. I can tell you, I can assure you, people are listening us in the future because we are not live.
Yeah, of course. So yes, so launch week for your company, Postgres AI.
Yeah, for the first time, I'm excited. Yeah, so we decided enough observing how others do it. First of all, Supabase. They just had launch week before this. I think number 15 already.
Yeah.
So many. And since our team has grown and we had stuff accumulated to be released, so instead of releasing it earlier, I said let's just accumulate a little bit and release in 1 week. It's like sprint, 5 days in a row. And we are releasing more. I hope we released by the time people are listening. I hope we released more than 5 things. So we have also concept of extra bonus releases. Yeah. And we started on Monday. We started with DB Lab version 4, which actually took 2 years to develop.
Yeah, that's a long time.
Yeah, finally we polished it and many users already installed it. I mean, release candidates. We needed to have 5 release candidates this time. It's too a lot of polish.
That's more than Postgres.
Yeah. Well, because a lot of new problems appeared because we changed a lot there. Yeah, but it's another story. Today we talk about our second big release, which is called Postgres AI monitoring.
Yeah, so this is one you're doing. So we're recording on Monday. This is one you're doing tomorrow. So what is it? What are you up to?
Yes, we are doing this tomorrow. Everything is ready already, so I'm pretty confident we are doing this. Yeah, and only few people know that we are releasing this kind of monitoring. And it's called Postgres AI monitoring, but right now there is a little AI there. And this is intentional. Let me explain this first, because of course we had a short chat before recording and you noticed this like discrepancy, right? So we use AI a lot, like every day. It's, for example, in my team, it's prohibited to do anything without AI first. It's prohibited to write code. Yeah, it's already so. Well, you can write code, but only if your AI tools failed. And first, people were resistant to this. But
I would
now
be.
some people said like, what the heck? Like I don't want it. Like it's bad. Like it's poor quality. But in my opinion, Anthropic release of Claude 4 a couple of months ago, it was a game changer. And quality already very acceptable in many cases. Not always, sometimes, especially if you are expert in some narrow topic, you understand problems which were never discussed publicly, right? In this case, of course, you will see like AI will be wrong 100%. And we have these cases like, for example, a perfect example is our guests last week. They experienced some problem which was not covered by public discussions.
Yeah.
So obviously, in such cases, if you just apply AI in straightforward way, it will hallucinate some bullshit. But if you apply AI to brainstorm some ideas and ground it, pre-ground, post-ground, with materials, reliable materials like source code, documentation, information from reliable sources, and experiments, post-grounding. In this case, it's different. So you can explore behavior, reproduce it, and this is the path we chose. Like, not just this problem, take AI and create, I don't know, like change request somewhere. This won't work. Ungrounded approach won't work. So this is one point. Another point is that 6-7 years I keep talking, I avoid building monitoring system. You know? For example, when I met with Lucas Fittel in San Francisco one day a few years ago, I told him this, like, you're building great monitoring system, PG Analyze. We built some checkup because we need for our customers to find problems and then to start exploring them, experimenting. Like, our key strength of Postgres AI team is experiments. That's why we built DB Lab to simplify specific type of experiments and benchmarks and so on. And I mentioned checkups, and somehow Pigeonalize has checkup section since then, but it's different story. And I said I'm not going to build monitoring system, but it was inevitably like I was pushed somehow to this point where it's inevitable that we need to do it, because no other system, and not only open source system, not other system is providing abilities we need. We need several specific abilities. With our clients, we always show it. And some of them is for troubleshooting. So like very high level analysis of Postgres components, and then you can understand where you can dive deeper. And actually, I remember great talks from Perkona, from Zaitsev, and so on. And I saw some bits of good stuff here and there, like Perkona monitoring, management and monitoring, or how is it called?
PMM, yeah.
Yeah. And things like use and four golden signals, approaches, like methodologies. Some great pieces there. But then you see something is really missing. Like, for example, proper query analysis. We talked about it so many times. Comprehensive analysis using pg statements, pg.cache, pg sampling, top-down, single query with query texts, with proper characteristics. And we didn't see any system like this. And a few years ago, we started maintaining so-called PGWatch 2 Postgres AI edition, which is was a fork of PGWatch 2 with our metrics and dashboards. That's it. But then Pavlo Golub decided to rewrite PGWatch, right? So we started lagging in terms of this vehicle we used as PGWatch itself. So time has come and we realized, okay, and we experimented a lot. We actually started with InfluxDB. It was insane. We eliminated it. We used timescale DB, and then we had a big thinking process. Should we stay with pure SQL and timescale DB, or we should use PromQL? And we decided to use PromQL, but with some nuances. We still have Postgres inside. So we have both Prometheus and Postgres. So idea was we need to build a new monitoring system, which will be part of our process. And in consulting, we had maybe 30 clients over the last, say, 1 year and a half. We had many, like few dozens of clients, right? And to all of them, we installed always our PGWatch 2 Postgres AI edition, and also used Postgres checkup tool, old tool we always used, to generate reports in static form, like Markdown or HTML, PDF. And it was not super convenient. So this time we said, okay, we finally do monitoring, but the main part of it will be open source. So monitoring itself is open source, but it's a part of bigger picture where we perform health checks and help clients proactively using AI, of course, right?
So I'm going to ask your question always. When you say open source, what do you mean? Like what license?
License is Apache 2.0.
Very nice.
As I remember, PGWatch is it BSD or Postgres license? One of these two, but our dashboards are Apache 2.0, so anyone can use it. Majority of that is so we couldn't use so-called like traditional Postgres exporter for Prometheus because it lacks so much stuff and it's really slow to put pieces there. So basically we have our own exporter inside, I mean metrics and dashboards, right? And it's Prometheus. Why Prometheus? Because we just see that in many cases, well, several reasons. One of the key reasons is that we had already three companies where we, in consulting mode, we contributed a lot to implementing our approach to their own monitoring system. So this is why we have confidence this monitoring system is great. And usually bigger companies, they have some stack. Some people use Datadog, but if you have 100 terabytes of data or say 1,000 clusters like microservices, Datadog is super expensive. Some people still keep paying, but even it's not only expensive. It has blind spots in terms of Postgres monitoring. A lot of them, for example, PGSub statements, they have some not all metrics, and for essential metrics, they, for example, can give you per call but not per second, or per second but not per call. There is no completeness there. Yeah,
Sure.
if you check carefully, so they differentiate in one dimension but not another. For another metric, it's vice versa. So it lacks many things, and also how dashboards are organized. I don't understand why people put tuple stats on the front page. It's not the main metric to observe. Not the main metric. Like, it's not number one thing you want to see when you have incident and need to troubleshoot. You know?
Yeah.
And people don't put queries per second because Postgres doesn't have queries per second. but we can extract it from PGSub statements with some asterisk that it's approximate because some things can be lost. Sometimes we see queries per second are lower than transactions per second, but it cannot be so, right?
Yeah.
In fact, because we don't see full picture, but in most cases it's vice versa. We see vice versa. So this monitoring is open source fully, and it can be used in pieces if your organization already has Prometheus-based something. But
which lots do, yeah, makes sense.
Yeah, but lacks a systematic approach for dashboards. This is where we can. I mean, you can take this and improve. Take pieces, maybe contribute back. Also good idea to contribute back always. Yeah, and I still think, although I personally invested like more than 5 years already to this. First few years I wanted to say no, I'm not going to do it, but then I was forced. Well, life sometimes forces you to do something, right? And now this is my I resurrected to this idea. Like, okay, I'm doing this, right? And and not only we have really super experienced members in our team who also spent a lot of time thinking and contributing to this. Like, it's not only my own effort, right? So we have several very good team members who contributed a lot. So we decided to use PromQL also because of these, because it's more compatible with enterprise systems.
Yeah, you mentioned using Prometheus, but also Postgres.
But also Postgres, because in Prometheus there is a problem with query texts. In query analysis, you have PGSub statements, but in Prometheus it's not normal to get query and store it. It's very inefficient. So you need a secondary storage, and we chose Postgres, obviously. Basically, we have two data stores. One is the main one is Prometheus, and the second one is actually we are debating right now. We probably will Prometheus. It will be Mimir. We also thought about Victoria metrics, so it's still we will switch in the next few releases. We will switch to something else. And for query text, it's Postgres, but it's small one. Because by default PGSub assessments for each node 5,000 statements. And do we track all of them? I need to check. Maybe no. So one of the things we noticed, we had cases with our previous monitoring that sometimes people have millions of objects in database, and this is really requires optimization. And we made this optimization for really large cases. I remember our checkup actually also had cases with 100,000 indexes. In case of monitoring PGWatch 2, it was a previous version, basically, right? Our Postgres AI edition, we had cases with more than 1 million indexes and hundreds of thousands of tables. Bloat analysis was not working, but and this is interesting and a separate question, how to perform index maintenance in such situation, for example. But
it's also a weakness of PGStat statements, right? Because often, I don't know if this is the case always, but often when you see that number of objects, it's because somebody's doing per tenant, but by schema. So a lot of the tables are the same dozen or several dozen tables and indexes. And then PGStat statements kind of falls flat on its face because it sees objects as unique and it tracks them all individually. So you can't look at,
It's flooded.
yeah, and 5,000 is not enough.
It's not aggregating properly.
Exactly, yeah.
Yeah, we discussed this recently. Also, there is a problem with temporary tables, for example. Sometimes, yeah, it's like the same schema, same table, but somehow you end up having different queries, two different queries in PGSA statements. And yeah, I would personally prefer some control how aggregation is done, right? There is
Interesting.
compute ID mechanism, right? So compute query ID mechanism. So basically, it would be great to define a rule, for example, ignore namespace, ignore schema name, right?
Yeah, wow. Yeah, interesting idea.
Yeah, maybe.
Because
I
the
don't know.
the table names will probably, for most people, the table names would stay the same. It's the
Yeah.
schema name that would change. Yeah.
When analyzing logs, I still prefer. I know, like since Postgres 16, we have query ID in the logs. We can have. We need to enable it for auto explain. But I still often prefer Lucas Fittles. Already mentioned him his second time. His great library, libpg query, and calculate fingerprints. I know it works purely based on syntax. No OIDs from PG class or something, right? So I know how it will aggregate, right? And it's mostly often often it's enough. Yeah. So
Do you know do you know if it can handle that? The like different schemas, same object name?
well, I think it distinguishes them. If query has fully qualified names involving schema name, I think it will produce different fingerprints. But I guess it's easier to tweak it than to try to change
Maybe. Yeah.
PGSA statements approach and so on. I don't know. I just feel, yeah, it would be great to have some more flexible, some default path, but some like exotic paths to tune it, how we aggregate, right? Because otherwise you end up like you have 5,000 slots in PGSA statements by default. And then maybe 5 different queries, each 1,000 times, right? But just with some differences. You know, the in problem, I don't know. Was it fixed already? I know, for example, libpg query, regardless of the members of in list, it will produce the same fingerprint value.
Nice. Okay.
But
I don't know if each set statement's got fixed, but yeah, you're right. If there's like the difference between having one in list versus 2 versus 3, they were all considered unique.
Yeah. Some people implemented some regexps to convert it before like calculating something. Well, usually you want, if you have in list, regardless of number of members in the list, it should be considered the same. Semantically, it's the same. Two members, 3 members, it doesn't matter. But PGSA statements, until like I thought I saw some discussion. I like my memory already tricks me sometimes. Maybe it was.
There's
fixed.
definitely been discussions. I just don't know if there's any commit. I think gut feeling is it might be in a very recent version, but I'm not 100% sure without checking. But like for example, any if you transform it into a query with any, you're going to get the same entry and PG set statements every time. So why should it be different with in list? Like it doesn't make sense to Although they could have different plans, like at a certain point they could flip the plan, but that's true of any query. That's true of any querying PG set statements.
How they work with not in and nulls, right? Remember this danger, right? So
yeah.
So let's discuss. So open source, Apache 2.0, open source components, PG version 3 as like engine for this. So we just
PG Watch,
PG Watch 3 version 3, which was written by Pavlo Golub, Cybertech. Great work, a lot of optimizations, a lot of things like how we control, they call it sinks, right? Like how data streams are controlled and so on. Yeah, and what else? Like very fresh Grafana, obviously, right?
Yeah.
And there we have several interesting tricks there. So where does these dashboards shine? If we talk about only dashboards, as I said, it's a part of bigger vision, but just talking about dashboards and manual use of them. First dashboard is the troubleshooting dashboard. You have just 1 minute and you need to understand where to dig further, right? we use 4 golden signals there. So we have throughput, latencies, errors, what else? Saturation, right?
Oh, I didn't see that one. Dashboard. Okay, dashboards.
Dashboard number 1.
Active session history.
Yeah. No, active session history, this is where it starts. But it's so single node performance overview, number 1. Active session history, in our opinion, like we convinced after many years observing like how RDS does it, how others also convinced. Wait event analysis is the king in monitoring. If you want one single graph, or how to say chart, this is to understand like quickly performance and what's wrong. This is what you need to look at. That's why we put it on the very first place, on the very first dashboard. But it's only very high level, like 30,000 feet view. So only wait event types, not wait events. No query IDs, not particular wait events, only wait event types. So it's very like, is it like CPU or IO or something? And CPU we mark with asterisk because it's not only CPU. We know sometimes some parts of the code still are not covered by wait events. So technically it can be CPU or unknown wait event, right?
Yeah.
And CPU is green. As everywhere, as in performance insights, patch viewer, anywhere. Yeah, so then we have very high level pieces of understand workload and various Postgres components. And we follow 4 golden signals there. So latency, traffic, saturation, traffic throughput, right? Saturation, errors. Latencies we extract from PGStar statements. I think it's a great idea actually to have it PGStar database. Probably there are reasons why it's still not there. You can extract it if you have pgbouncer. Sometimes I just check pgbouncer logs manually to double check that I understand latency properly. From PGStar statements, good enough. Of course, again, if you have situation like we just discussed, and you see only the tip of the iceberg in those PGStar statements.max entries of PGStar statements, 5,000 by default, then it will be wrong value. So I think, we understand this, right? So it's like best effort.
It's kind of an edge case as well, right?
Yeah.
It's not many people that have hundreds of thousands of objects.
Yeah. And throughput, we like in various ways, like calls per second, transactions per second. So these are key ones. And we didn't put tuples per second, as you can find in Datadog and some other places. Maybe we should, but I'm not convinced this is super low level throughput metric should be on the very front. Maybe actually, because I'm contradicting with myself. I'm always discussing logical replication. I say on modern Intel and AMD processors, single slot, single publication subscription, it can saturate subscriber side, single threaded process at levels like 1,000, 2,000, 3,000 tuples per second, depending on various factors. So maybe tuples per second for writes, maybe we should put it actually. Good idea, maybe, right? But this is very low level of throughput. So in database, you can understand throughput in various like levels, transactions, queries. Well, tuples next. Is tuples next, or maybe rows?
Buffers,
actually, rows.
volume.
Yeah, rows, tuples are different, right? Well, buffers. Yeah. Actually, this is what we do have. We have hits and reads and writes, dirtied buffers. All those buffers, we put it on right on the front page, but only high level. We don't distinguish by query ID. This is the job for different dashboard. So you quickly can understand what's happening here. Of course, we translate it to bytes, right?
Yep.
Yeah. So how many bytes per second of buffer reads your buffer pool is having right now? And did we have spikes, right? So, yeah. And and errors. Yeah. So if there are errors, we will see it in transaction analysis, number of rollbacks. We currently don't work with logs, but it's in roadmap, of course. So we extract errors from logs, aggregate, and so on. I still have hope that tiny but very useful extension called log errors one day will make it into engine, and we will have some pgstat errors or something. Pgstat errors, actually. Pgstat errors. It would be great to have some error code and how many times it occurred, right?
Yeah.
Basic cumulative metric, and we could start observing them in normal way, exporting, and then alerting. Speaking of alerts, it's also in roadmap, definitely. Yeah, we have very careful approach, because talking to different customers, we see very different expectations, very like opposite sometimes. So I will discuss it, in the past.
Well, I think it's interesting. I think alerting is fascinating, and like balancing risks of false positives versus risks of false negatives. Like, I think it's a really hard problem.
It's a hard problem.
And configuration, like people always just end up making everything configurable, and it's then picking defaults is hard, or like anyway, it's not envious of people that make monitoring tools. They're quite like making it simpler.
I think we will avoid a single default set of defaults, and we will just give some like basically questionnaire. What matters for you more, like this or that, and based on that we adjust the setting right away. So
like like when people first install it, there's like the old school wizards that you go through and answer a bunch of questions, like, and then interesting.
Old school type form, you know. I'm joking. Type form is already old school. Yeah. Because I see, you know, like dental clinics use type form already, you know. Like it's not cool already. It's old, ancient. Yeah, I love type form. I love the fact that you can use only keyboard, no mouse involved, navigate all the questions, answer them. So anyway, alerts is a separate topic. It's in the roadmap, not right now.
Mm-hmm.
We also paid very careful attention to metrics we display. We had many debates about this, really. And like for example, if we just talked about, for example, buffer reads per second. Okay, we translate them to bytes. So okay, megabytes, mebibytes, gigabytes. We use lowercase I in the middle to emphasize it's gigabytes, megabytes. So if we display it on axis Y, is it megabytes or megabytes per second? And I don't see consistency in various monitoring systems. So I managed to convince we should display megabytes per second. And to convince, I just said, okay, actually, you know what? We have all these metrics. It's differentiated by time. So if you display a raw metric, it will be constantly growing. It's cumulative metric. It's just number which always grows until you reset it. So since you differentiate it by time, it becomes like already like spiky or some kind of normal behavior, right? So it should be maybe by second. But also, as I said, notice we develop additional differentiating on the right side. Almost always you can find a chart which is displaying the same metric per call, average per call.
So flipping instead of per second, per call.
Exactly.
Per query, kind of.
Yeah. So if it's, for example, execution time per call, it's average execution part of the latency, right? If it's
but what does execution per second mean?
No. Total
one
exact
you
time
can't do.
Total exact time per second you can do. This is the key metric. This is the central metric in our approach. It's measured in seconds per second.
Seconds per second?
We discussed this. Yes.
Oh,
I'm glad we're repeating this topic. This is key metric.
Yeah, me too. I've clearly forgotten it.
Seconds per second is a key topic, a key metric. My favorite metric. It shows you how many seconds database spends to execute your queries per each second.
And then do you have to divide it by cores to like understand utilization?
No. Wait. It's two different things. We have some metric, for example, number of buffers, which is also always growing across all query IDs. Here it's top level. We just summarize all of them, all 5,000, right? Or we have total exact time, right? These are two raw metrics. They are always growing. You can let Grafana, basically PromQL using iRate. You can let it differentiate by time. You will we don't use mean exact time because we can have it from different place. Or you can divide it by calls. If you divide by calls, you have basically the same value as a mean exact time, but not Postgres calculated it, but PromQL calculated it, right? But if you divide it by time, it's differentiating by time. You will see how it changes over time. Every second we spend, for example, 10 seconds. Give us at least 10 cores for this workload. It's very roughly. It doesn't fair because this time can include waiting on log acquisition, right? Or I/O. It's like it's not true CPU user or system time or something. But roughly, it gives you good understanding what kind of like the scale of your workload. If it's 10, don't run it on 2-core machine, right?
Yeah. Well, more to the point, is it growing over time, or is it are we reaching
Spiking.
some when are the spikes, that kind of thing? Yeah. Interesting.
And if you divide it by calls, you have average. So that's why we say metric per /s per second. And if it's seconds per second, we transparently say s/s, seconds per second. Why not?
Okay. Well, I just think it hurts my head even thinking about it. I think there's sometimes a case in products for being accurate and sometimes a case for being simple or like easy to understand at first glance. And it depends who you're building for, right? Like accuracy is extremely helpful, especially for deep experts. They want precisely what happened all the time. But anything that could be distracting for folks who don't necessarily know what they're doing.
That's a great point.
Yeah. So, you've answered pretty much all the questions I had already, except for who is I know yourselves are your ideal user, but like who is your ideal user for this product?
Honestly, 99% ourselves. We do it for our own work, for consulting, but we see it beneficial to publish it as open source. So first of all, our clients could verify what we are collecting, right?
Yeah.
Even Datadog publishes exporters, right? So it's fair. But for us, these dashboards, it's not final product. By the time we publish this release, it's already obvious. We already included this to workflow where metric collection is step number 1 of big step number 1. It's just first half of the step number 1. Mm-hmm. Dashboards is step number 1. And then API is exporting dashboards in form of static tables. Actually, we didn't get there, but our dashboard with query analysis includes not only graph view charts, right? But also table view like our Postgres checkup had. And table view is super beneficial because you can compare for each query ID. You can see many different metrics in one row. And you can understand much better looking at very compact form of representation. It's for experts. It's not for non-experts. Like regular backend engineer needs some time to understand how to work with this. It's possible. Yeah. We did it, but it really needs some time. But since I said this is big step number 1, this dashboards and charts and tables and everything. Second step is analysis by experts, and experts can be humans or LLM. For efficient analysis, you need to transform raw observations. We call it we transform observations to conclusions. You have some transformations where it's quite like we did with buffers. Okay, 1,000 buffers. Even for expert, it takes some time to understand is it big or not. But then we multiply it by 8 kibibytes, and we have 8,000 kibibytes, roughly 8 megabytes. Not exactly, but roughly. And we say, oh, okay, this I can feel already. I know how long does it take to get it from disk, or how much of memory it takes. I already feel it, And my hypothesis in what we are doing is that both experts and LLMs work better with this transformed raw data. If you present it better, This is what we do on second stage. Second stage, we transform observations, very raw, to conclusions, but we don't add thinking there. Maybe a little bit, a little bit. Not debatable type of thinking, quite like straightforward logic, Like we can calculate percentage, for example. This query ID in buffer hits takes like 25%. It's very noticeable, 1/4 of whole hits traffic, So
it sounds like the kind of arithmetic that's difficult to do on the
Yeah,
fly accurately when you're in the middle of an outage or
yeah.
something.
It
Help people.
includes everything like arithmetics, like formulas. It also can include some representation transformations, like put these numbers closer to each other. Just by putting this, you highlight that they have some correlation or something, you know?
Yeah.
Also, take specific charts. This is already like methodology we develop over many years, how we approach analysis of various problems. But still, we don't put conclusions there because we just observe. We just slightly transform what we see to better form for consumption of by experts still and LLMs. And final thing is recommendations and understanding problems. Not only recommendations, first understanding problems. So we see problems and we already start thinking. This is already sometimes, if you take two DBAs, they have two different opinions, you know,
Yeah.
what they see. Here is already tricky part. But our idea is, okay, we have brainstorm phase, collection of hypotheses. And then since we build very great lab environments, we have thin clones, we have thick clones, we can have different tests, and we can verify ideas on thin or thick clones, right? Or maybe in synthetic, sometimes it's just before you sending bug report or raise some discussion in hackers, you need to have minimal viable representation of your problem in synthetic form, not to share personal data, right? From production.
Reproducible test case.
Yeah. It should be minimal. It's also a special type of art in database operations to extract from production some minimal stuff and inject it. And here is where LLM can be very helpful to iterate much faster.
Yeah. I find this difficult for blog posts as well, like coming up with an example that you can like share anyway, yeah, it's an art and very impressive and takes way longer than it looks. Well, at least it does for me.
It should take less. And I hope AI, I don't hope AI is already improving this, but I think we are on the edge of massive improvements in this area.
I really hope so. I've tried it for I've tried using even Claude 4 and I've with limited success.
Yeah, I know it. Yeah, I know. I know some problems like you just give up, and you know, we spent whole last year experimenting so much. We had credits from. We still have it. We still have credits from Google Cloud,
Gemini,
experimenting. Yeah, Gemini. Like, Gemini excels in some parts of work, but not in all. And of course, Claude is also not the final like answer to everything. But I see many there is a substantial improvement with Claude 4 release. Substantial, like significant. So it gives me a much like more like level of excitement of how we can move forward. So anyway, this is our whole system. And right now, almost everywhere there is human because we don't trust. And it will take a few years to start trusting more. And maybe LLMs should be, well, they don't stop. They are improving, right? And knowledge base is growing also, right? So our knowledge base is growing, which we use when we work with LLMs to improve quality of answers. And so this is how I see it as a component in the beginning. It can be used directly if you're an expert, or you can spend time understanding some documents, like to dive deeper to details, and then not becoming expert, but already to start understanding how things work, right? And then we transform it to form which is easier to move faster, basically, not to jump between various pieces. We already, for specific analysis, we compile multiple reports to a small report, which is for this specific analysis. For example, our checkup has a report called memory analysis. Memory analysis, if you want to tune memory, not only you need to tune shared buffers, maintenance work mem, max connections, but also check what's happening with your number of auto vacuum workers. And also remember that in Postgres 17, before Postgres 17, even if you raise maintenance work mem beyond 1 gigabyte and put it like 8 gigabytes, thinking, okay, I'm going to create or recreate indexes only in one, basically in one session, But auto vacuum workers, you have them like you also raise number of auto vacuum max workers. You raise it to 10, for example, and you think, okay, I know that. Well, people don't know mostly, and I also didn't know until recently. But before 17, if auto vacuum work mem is -1, it means that it inheritance from maintenance work mem. But maintenance work mem, if you raise beyond 1 gigabyte, it's still auto vacuum cannot use more than 1 gigabyte. But this was changed in Postgres 17. It can use more than 1 gigabyte right now. So if you tune it before and you then upgrade, you can run out of memory suddenly. If you perform auto vacuum tuning in more, like we always say, raise number of workers, give more memory to workers to backends which build indexes. Now you upgrade to Postgres 17, mathematics changes, right? So we have a report which collects all the pieces and involves version and knowledge about these changes. Right? Like it requires some expert work, and we should not live in the world where this work is done manually, right? So it should be done like in automated fashion, collecting pieces, analyzing things, like not to miss some important parts of the knowledge. Yeah. So LLMs there, definitely.
Well, not definitely. Like
Definitely.
you can get version you can get version. I'm intrigued as to how much you'll end up using LLMs on this journey, because things like the version information you can get directly from Postgres, right? You can run a query and find out what version it is. You don't have to work that out, or it's not something where like a language model is going to be beneficial.
Yeah.
And there's some, like, I don't do monitoring tools, but doing performance advice is like something I've learned to like try to get good at. And I thought we would end up wanting to write bespoke advice in lots of different cases, but it's amazing how you can word things so that they cover like different cases, or conditionally show different pieces of the advice in different scenarios and like piece together the full response without risk of hallucinations.
I agree with you. That's why on the first two steps we almost don't involve LLM, because we don't want them to like I cannot let LLM to summarize to numbers. I better use a regular calculator, right?
Yes.
Yeah,
exactly.
That's why
there are some things previous generations of commuting were fantastic at.
Yeah, that's why jumping from observations to conclusions, we basically don't involve LLM. We involve our methodologies we developed, how we analyze things, and we just transform. We don't need LLM there. But when then we have problems, first of all, we need to understand which problems look most critical. This, I believe, can be done, at least preliminarily. LLM can highlight what's the most critical. And then, most important, start hypothesizing about like trying to understand root cause, trying to prove it, build experiment to prove it, and then how to solve it, build experiment how to solve it, prove that it's like drive this very hard work of root cause analysis and finding mitigation, This can be done by LLMs because it can search similar results on our knowledge base and internet, right? Find like ideas, and using thin and thick clones and frameworks we built with Postgres AI, it can start experimenting to check and to prove, this is what's happening here, Of course, the problem we discussed last week with metronome, guys, it will take time for us to reach a point where our system will perform full-fledged root cause analysis and experimentation part. But I would say it's like 1 or 2 years only. We already had a lot of pieces built on this road,
Well, I look forward to discussing it again then.
Yeah.
Nice one, Nikolay. Looking forward to it. Good luck with the rest of your launch week as well.
Thank you.
In the past.
In the past, yeah. Back to the future, or how to say. Good. Thank you so much.
Nice one. Take care.
Thank you. See you soon.